Okay, we are going to find yp of this differential equation by using shortcut method. This example is just different from the previous example in such a way that this example we have the boundary condition. So we have to find the equation. No, actually this one got to be find the solution of this differential equation. We can't find the yp if they give you the boundary condition. Okay, so find the solution of this differential equation which is satisfied with these two boundary conditions at x equal 0, y is equal to 1, and at x equal to 0. The first derivative of y is equal to 0. Okay. So because this is a non-homogeneous differential equation, so the answer would be yc and yp, right? So we find yc first. For yc, you got to write the characteristic equation. For this equation, what is the characteristic equation? M squared minus 1 equal to 0. So we find two values of m, which is m minus 1 and m plus 1 equal to 0. So that means m is equal to minus 1 and 1. So our yc is equal to c1 times exponential of minus x plus c2 times exponential of x. So next, we are going to find yp. We are going to use shortcut method to find yp. Okay. So in that case, we got to write our differential equation in terms of operator. Okay. So then we got d squared minus 1 times y is equal to minus x squared. Right? Because our definition said that if we have d, it means if we have dy, it means dy by dx. So if we have d square y, it means the second derivative of y by our dependent variable. Okay. So from that, we would get y is equal to 1 over d squared minus 1 times 2 minus x squared. 2, actually, it seems like we have x to the power 0 times 2, right? So I would say we have 1 over d squared minus 2 times 2 minus 1 over d squared minus 1 times x squared. Our operator have the property of distribution. Okay. 2 is a constant. Constant, can you take it out? You can take it out from our operator. So we would get so whatever we're doing now, we are only the first case, right? First case is just that fx. Our fx is in the term of power, right? X to the power k. Now, the way to solve for the answer of this is just that you've got to write the term of 1 over pd in the term of b0 plus b1d plus b2d squared plus until the power of our d is equal to the power of the x, and the rest of the term will be equal to 0. Okay, so in order to make the 1 over d squared minus 1 in the term of b0 plus b1d plus b2d squared and so on, we got to write this pd by putting the constant at the front. And then you just do the dividing term. Inside is 1. What's the number times minus 1 equal to 1? Minus 1. What's the number that you time with minus 1 equal to b squared? Right? Minus d squared times minus 1 equal to d squared. But now we have d squared. Do we have to do to make it in the higher order? No, because that's the maximum power of our x is 2. So other term which has the number higher than 2, if you do the differential of x squared, you would get 0. So you don't need to go further for that. Okay? So we would get x to the power 0 is equal to 1, right? So just distribute this term in here. Differential of derivative of constant equal to 0. So this term just equal to 0. So you got minus 2 plus x squared. The second derivative of x squared equal to 2, right? This term, because dx squared by dx is equal to 2x, right? d square of x squared by dx squared is equal to 2, right? So this term is equal to 2. Which is equal to x squared. So yp of this differential equation is equal to x squared. Now we say y is equal to yc plus yp is equal to c1 times exponential of minus x plus c2 times exponential of x plus x squared. But this is not it yet, because the problem statement is saying that we have to find the answer which is satisfied with our two boundary condition, which is saying that at x equal to 0, y is equal to 1. So we just put this boundary there, we get 1 is equal to c1 plus c2 plus 1, right? So that means c1 plus c2 is equal to 0. And the other boundary condition is saying that the first derivative of y is equal to 0 and x is equal to 0. So we got to do differential of this y. To do that, we got the first derivative of y is equal to minus c1 exponential of minus x plus c2 exponential of x and plus 2x. So we got 0 is equal to minus c1 plus c2 plus 0. So that means, why they're all 0? C1 is equal to C2. Did I do something wrong? But this one saying that C1 is equal to minus. Oh yeah, this one is equal to 0. So C1 plus C2 is equal to 1. Right? This is our first equation and this is the second equation. We put 2 into 1. We would get 2C1 is equal to 1. So C1 is equal to 1 over 2. And since C1 and C2 are equal, so I would say that C2 is also equal to 1 over 2. So the final answer is just that y is equal to 1 over 2 times exponential of minus x plus 1 over 2 times exponential of x plus x squared.